So guys, let's take a look at this question looking at vector diagrams and resultant force. So it says a boat moves through the sea. There is a 3000 Newton force to the west on the boat, and there is a 1000 Newton force to the south on the boat. And it says determine the magnitude and direction of the resultant force on the boat. Draw a vector diagram of these forces to scale on figure 2. So figure 2 being this grid square that they've given us. Now for this I would definitely recommend you need two things. You need a ruler and you need a protractor. So I'm going to explain how to attempt this question, but obviously when I say it you would use a ruler and a protractor at the certain points that I mentioned. So to start with, we are referring to the 3000 Newton force to the west. So they've given us a direction as well. Yeah, so that's to the west, north, south, east, west. West is pointing to the left. So we need 3000 Newtons of force going to the left. And then it says 1000 Newtons of force to the south. So that's downwards. So we're going to have a force going 3000 to the left and 1000 downwards. Now, what you want to do whenever they give you squares in a grid, you want to make as much use of the space as you possibly can. Yeah. So because I can't measure with a ruler, I'm going to go by grid squares. So I want 3000 to the left, 1000 downwards. So my horizontal distance is going to be 3 times longer than my vertical one. So the grid squares here are 13 by 6, so 13 wide and 6 squares down. So to make my 3:1 scale, I'm going to make my 3000 Newtons go 12 squares to the left, which takes me to here. And then if that's 12 squares, we know that it's 3000 Newtons. So I'll put 3000 Newtons on my arrow here. And then we know that the 1000 Newtons is going south, downwards. So that's 3 times smaller than this horizontal force. So if it's 12 squares across, 12 divided by 3, that's 4 squares down. So I'm going to go 4 squares down from that corner. So when you're looking at a resultant force, you want these forces to be a combination, so they follow in a path together. That's why I've done 3000 to the west first, followed by 1000 Newtons to the south. So now we have these two forces. And we know our resultant force is going to be, as the name suggests, the result of these two. So from the starting point to the end point here. So I'll take a different color and I'll show you from the beginning in the top right, we then draw an arrow straight across to where we ended up at the bottom left there. So this is the arrow for our resultant force. Now at this point, what I would do is I would have measured the length of my two forces to come up with a scale to say 1 centimeter equals however many newtons. Yeah, so we know per centimeter how many newtons does that refer to. I'll then use a ruler to measure this distance, which I'll say in blue, to measure the distance of our new arrow. And